For this general instructions video, we will be looking at a water molecule that I have already drawn. For performing energy minimization, once your molecule is drawn, click the Minimize button in the bottom right-hand corner of the model kit. Wait for the message Minimization Completed to appear at the bottom of the screen before proceeding. To perform a geometry optimization, click the Setup tab and then Calculations. A dialog box titled Calculations will pop up. In the Calculate subsection, select the following from the drop-down menus: Equilibrium Geometry, Gas, Density Functional, B3 Lip, and 6-31G star. Note here that if you are optimizing a cation or anion, ensure that you select cation or anion accordingly from the Total Charge drop-down menu. Similarly, if you would like to view an IR spectrum for your molecule, check off the box next to IR. Lastly, ensure that Global Calculations box is checked off and click Submit. Save your file as the molecule name _GO for geometry optimization and save it to the appropriate folder for the experiment you are working on. To view the time remaining on your calculation, click the Option tab and then click Monitor. A dialog box will pop up listing any queued calculation. Our calculation for water was quick and already completed, but they would be listed here. If you are still unsure whether your calculation completed, click the Setup tab and Calculations. If your calculation completed successfully, you will see this notice here. Alternatively, you can click the Display tab and Output. In the last tab under List Output, you will see Analysis completed successfully. Next, using the same water molecule, we will view electrostatic potential map and the dipole vector. Once your geometry optimization is completed, click the Display tab and then Surfaces. Then, in the dialog box that pops up, click More Surfaces. From the drop-down menus, ensure that Density, Potential, and Medium are selected. Check the box next to Fixed and ensure that the value 0.0020 is selected. Then click OK. Wait for the status column to say completed and check off the box next to Electrostatic Potential Map. Exit out of the dialog box. Right-click your structure and click Properties. Under the Style section of the dialog box that pops up, select Transparent and exit out of the dialog box. Next, we will view the dipole vector. If your electrostatic potential map has a pin, you will have to right-click the pin and select Delete. Next, click the Display tab and Properties. Under the Molecule tab of the dialog box, check off the box next to Display Dipole Vector and exit out of the dialog box. Next, we will be viewing HOMO and LUMO orbitals for the same water molecule. First, click on the Display tab and then Orbital Energies. Alternatively, you can click the Orbital Energy buttons from the toolbar. On the energy diagram that appears on the left side of the screen, click on the HOMO line to view the HOMO orbital and the LUMO line to view the LUMO orbital. Now we will be viewing charges on individual atoms. If your orbital energy diagram is still selected, deselect it by clicking the Orbital Energies button from the toolbar. If your electrostatic potential map is still showing, you will have to click the Display tab and then Surfaces and uncheck the box next to Electrostatic Potential Map. There are two options for viewing charges. Option 1 is for viewing all Mulliken and electrostatic charges listed. First, you will have to label your atoms. Click the Model tab and then Labels. Numbered labels will appear on the atoms of your molecule. Next, click the Display tab and Output. A dialog box will appear. Under the Summary tab, click the drop-down menu for atomic charges. Mulliken and electrostatic charges are listed for the corresponding labeled atoms on your drawing. Option 2 allows you to select atoms and view their electrostatic charges. Right-click any atom and click Properties. The electrostatic charge for the atom will appear under the Charges subsection.